Hi there. So in this section, we're going to be looking at the algebra of functions. At the top of this set of notes, you're picking up a little bit of an introduction of a little bit of new notation for the composition of functions. But hopefully these really are very intuitive and make sense to us that f plus g of x written in the manner that they're written over here on the left is equivalent to then f evaluated at x plus g evaluated at x. Likewise, for f minus g of x, that's equivalent then to f evaluated at x minus g evaluated at x. And then lastly, when your letters are side by side, that indicates multiplication. So that means f of x times g of x. I typically myself utilize the notation over here on the right as opposed to the notation on the left, but just know that they mean the same thing. And while we're here, we are going to be talking about domain again. So let's go ahead and talk about domain for this particular, those top three notations. The domain of any addition, subtraction, or multiplication of two functions, your domain is going to be equal to the overlap of f and g, your two functions. Now, my notation here is using the functions f and g, but you could use any notations. It could be a function h and k, for example, or a p and a k. So it's the overlap of the two functions themselves. While we're here, it's probably a good idea to let's do a quick domain recall because we will be doing domain extensively in this particular unit. So for our domain, remember there's three questions that you ask yourself. Number one, does your function have a variable in the denominator? Variable meaning letter. Do you have a letter in the denominator? In the denominator. If you do, then whatever that denominator is, you set that denominator not equal to 0 and solve for x, and that is going to give you then your domain. Second question then, if you answer no to that question, then you go ahead and ask yourself, well, does it have an even root? Does it, you mean your function it, does it have an even root? And what I mean when I say that is I'm asking, do you have a square root, a fourth root, a sixth root? So it's got to be an even root. If it were a cube root, it wouldn't matter, but it's got to be an even root. Remember, with square root, there's an imaginary 2 sitting out there. If you have an even root, then the argument, the piece underneath that radical, I refer to that as being our argument, then you set the argument greater than or equal to 0 and solve for x, and that's going to give you what your domain is. And hopefully you recall then, if you answer no to both of those, to both of those questions, if you answer no to both questions, then what's your domain? So you recall, the domain is equal to all real numbers, negative infinity to positive infinity. Okay, so that'll be how we proceed with finding our domain. Just that, and again, that's just a recap. That's coming back from our previous unit. All right, so the last one here is looking at a quotient of two functions. So f divided by g of x is equivalent to f of x divided by g of x, where that denominator cannot equal 0. So hopefully that makes sense to us as well. Because remember, if our denominator is equal to 0, then we're undefined. Here, to find the domain of any quotient, the domain is going to be equal to the overlap of f and g and wherever the denominator cannot equal 0. So you're going to overlap all three of those pieces to get your overall domain. All right, so let's come down below. I'm going to actually do this entire page here with you. If at any point, though, you want to stop, especially like here in example 1, I'll do letter A with you, but I'm going to go ahead and do B, but it might be a good idea after I do A, pause the video, try B on your own. Okay. All right. So coming on down below here to example 1, it says here's our given function for f of x and a given function for g of x, and it wants us to find these two pieces. So in letter A, it wants g minus f of negative 5. So again, let's rewrite this in equivalent notation. This means g is going to be evaluated at -5. Going to bring down that minus sign. And then f is going to be evaluated at -5. So the very first thing that I'm going to do then is I'm going to go to my g function. Everywhere I see an x, I'm going to plug in -5. So here's my g function. All right, I've got this negative sitting out there, and then I'm going to replace that then with my x with -5 plus 2. All right, so I have gone to my g function. I plugged in -5. I'm just going to leave that there, and we'll come on over here. Let's now go to our f function. I'm going to do the exact same thing, but this time I'm going to my f function. Everywhere I see an x, I'm going to plug in -5. So I've got -5 squared minus 3 times -5. And you'll notice how every time I substituted in -5, I use parentheses. It's really helpful in this first instance here because you already had a negative sitting out there, so that negative had to be brought down, and two negatives side by side will turn into a +5. Once I get that down to one number, which I'll go ahead and do, 5 plus 2, of course, is 7, I can drop those brackets. All right, but I won't drop it until I get it down to one number. The other important piece over here, when I went to my f function and I also substituted in using parentheses for that -5, if you were to rely on your calculator for -5 squared, if you don't use parentheses, your calculator is going to tell you that -5 squared is -25. In order to get the correct answer, because we know that -5 squared means -5 times -5, a negative times a negative is a positive. The only way for your calculator to give you the correct answer is to use those parentheses. And then here on the back end, -3 times -5 gives me a +15. All right, so I'm bringing down my minus sign. 25 plus 15 lands me at 40. Now I can clean up one last time. 7 minus 40 will get you a -33. Final answer. Okay. All right, so I'm going to come over here to letter B. I'm going to go ahead and try that one. This is virtually the same type of problem. F plus g, but this time I'm evaluating for an x value of -2. Again, I highly recommend pause the video, try this one on your own. What this means is I'm going to evaluate f at -2, bring down the plus sign, and then I'm going to evaluate g at -2. Okay, so now this says go to my f function. Everywhere I see an x, I'm going to plug in -2. So -2 squared minus 3 times -2. Bring down that plus sign, start me a new bracket. I'm going to my g function. Everywhere I see an x, I'm going to plug in -2. So that's minus sign that's already part of the g function. Then I'm going to replace that x with -2 plus 2. All right, just like before, I'm going to keep cleaning up now. So now -2 squared gives me +4. -3 times -2, +6. And that cleans up to give me a +10. Over here on the right, two negatives side by side turn into a positive. 2 plus 2, 4. Final answer then, 14. Okay. All right, I'm going to scoot on down then to example 2. In example 2, I am likewise giving you a function for f of x and a function for g of x. And this time I want us to find g times f of x, and we're going to add another element to it. We're also going to state its domain this time. All right, so let's first though find g times f of x. So remember, g times f of x, that just means g of x times f of x. So let's plug in what we know. G of x is my 4x minus 2. F of x is our -x plus 1. I want to multiply these two. If we agree, you got two binomials sitting here side by side. We can just FOIL this. All right, so if we go to FOIL, do my first. 4x times -x, -4x squared. Outside, 4x times 1, so +4x. Inside, negative times negative, that gives me a +2x. Last, -2 times 1, -2. Last step, clean up, -4x squared plus 6x minus 2. That is our g times f of x. All right, Let's see if I can't quite get it all on here. All right, so if you recall up at the top, it said that for the domain of any combination of addition, subtraction, or multiplication, the domain was equal to the overlap of your two functions. So to get my domain, I need to look at the domain of f of x, and I need to look at the domain of my g of x function. All right, so for my f of x function, I'm going to ask myself those questions. So for my f of x function, does this function have a letter in the denominator? Definitely not. Does it have an even root? It doesn't have a square root, it doesn't have any kind of root at all. You're answering no to both of those questions. Domain then, negative infinity to positive infinity. Likewise for my g of x function. Again, I'm just asking these questions that I put over here on the right for you. All right, so is that we're asking ourselves for my g function, does this function here have a letter in the denominator? There's no denominator, so definitely not. So that's a no. Does it have an even root? There is not a square root in this function. So you're answering no to both of your questions again. Negative infinity to positive infinity. So then what happens to get my overall domain, I need to overlap these two. And so if you think about it, if I overlap those two, if I do, I'll give you a visual here. Here's a standard number line. F of x said you get the full number line. And g of x said you get the full number line for the domain. And so I'd be looking for where they overlap. Well, they're overlapping everywhere. So my final domain then would be negative infinity to positive infinity. Final answer for my domain. Okay. All right, we'll come on down then to example 3. This time I have given you an h function and a k function. I'm asking us to find k over h of x and then also state its domain. All right, so remember this is what you're asked to find, k over h of x. So that means k of x divided by h of x. So let's substitute in what we know. We know k of x is the square root of x plus 5. H of x is the x plus 2. You cannot simplify that any further at all, okay? So that is your final answer for k over h of x, okay? That's our final answer. So now let's tackle domain. I'm just going to come back up here and I'm going to draw your attention to how do we find the domain of a quotient. Remember, the domain of a quotient is equal to the overlap of your two functions and where your denominator cannot equal 0. So you're going to see me calculate 3 things here, okay? So let's come over here for my domain. I need the domain of my two given functions. So looking at my h of x function, I'm going to ask myself those same questions. Here's my function for h of x. Does it have a letter in the denominator? It doesn't have a denominator, so definitely not. Does it have an even root? There's no radical sitting here, so definitely not to that. So h of x, domain, negative infinity, positive infinity. All right, let's move to k of x. K of x, here's your function. Do you have a letter in the denominator? There's no denominator, so no to that. Do you have an even root? Yes, we do this time, right? You got a square root sitting here. That's an even root. So then our rule up here for our domain said you set the argument, what's underneath that radical, greater than or equal to 0 to find out what our domain is. So I'm going to set here x plus 5 greater than or equal to 0 and solve for x. So it's just a one-stepper here to solve for x. Subtract 5 on both sides. So x is greater than or equal to negative 5. All right. And then lastly, remember you've got your two functions and your denominator cannot equal 0. So looking at my function here, here's my denominator. We'll make that notation for you. Denominator also cannot equal 0. So my denominator then was x plus 2 cannot equal 0. One stepper here also to solve for x, pull that 2 over. So we find x cannot equal negative 2. So now to find my overall domain, I've got to overlap this guy, and that one. Those 3 need to be overlapped to get my overall domain. So picture's really helpful here. So I'm going to come over here. Here's just a standard number line. All right, so the first one says you get the full number line, negative infinity to positive infinity for h of x. K of x said it's going to be all x values greater than or equal to negative 5. So let's put 0 here, sorry. So here's negative 5. Bracket at that negative 5. That inequality sign is pointing to the right, so I'm shading to the right. And that makes sense there. That would be all of the numbers greater than or equal to negative 5. And then the last one says x cannot equal negative 2. All right, so let me get a negative 2 on here. So let's say here's my negative 2. I can equal anything but negative 2. So hopefully you recall, what did that look like on our number line? We had parentheses on either side of that negative 2, and we were shading in both directions. So now, where the red, the blue, and the black are all on top of each other, that's where they're overlapping. So I can't include anything from negative infinity to negative 5 because the blue's not in that region. But I can go from negative 5 to negative 2. And then notice how the negative 5's got a bracket, negative 2's got a parenthesis. And then from negative 2 on, right, the red, the blue, and the black are all on top of each other. So negative 2 to infinity would be the last half of my domain. And that would be my final answer for my domain. Okay. All right, so now let's flip it on over. I'm going to do example 4 with you from top to bottom on the next page, and then let you try example 5 on your own and check yourself by the solution key. And actually here with example 4, it might be good to start yourself off with doing this first part, A, B, and C by yourself. That's typically, when I teach in class, that's what I tell my folks. Here, look at your f function, your g of x function. We've just done a nice review here of domain. Tell me what the domain of f of x is. Tell me what the domain of g of x is. And then what's the domain of any combination of addition, subtraction, or multiplication of those two functions. So if you would like, pause the video. If not, I'm going to go ahead and go on here. All right. So looking at my f function, I'm asking myself these questions. Does it have a letter in the denominator? Nope. Does it have an even root? Nope. You answer no to both of those questions. Negative infinity to positive infinity. Domain of g of x, same question. Letter in the denominator? Nope. Got an even root? Nope. Negative infinity to positive infinity is my domain. Any combination then of addition and subtraction of those two functions would be to overlap those two domains. And so if we overlap those two domains, we saw that previously in a picture. If you take negative infinity to positive infinity and overlap it with itself, that's what you still have. Okay. All right, so now let's move on down to letter D. In letter D, I want to find f over g and state its domain. Okay, so f over g, so f is my x plus 3, g is my x squared plus 5x plus 6. If you need help with factoring, I will post a factoring review for you here with this unit. It'll pop up just a little bit here in this unit, but it really pops up in the next unit. So I'm about to talk a little bit about factoring, and so if that's completely foreign to you, be sure you watch that video. All right, so here we can clean this up, is my point in saying this. This can be reduced further. So the denominator there can be factored. So I'm just going to bring that numerator over, and I can factor this denominator. The only way to multiply to give you x squared, x times x. And now in the bottom, I want to think about a way to multiply to give me 6, but then it has to add or subtract to give me 5. So there's only 2 ways to multiply to give you 6, 3 times 2 and 1 times 5. Usually splitting it down the middle is the most common way. So let's try with our 3 and 2 first. You always check your outside and inside. So on the outside I have 2x, inside I have 3x. My goal is this middle term here, which is 5x. I can get that. I can get 5 out of 3 and 2 when I'm adding and subtracting them. And here I'd have to add them both. But that's exactly what needs to happen, because then at the end you do your last double check. 3 times positive 2 gets me that positive 6 at the end. All right, so I'm going to erase kind of that stuff there. You can always check, anytime you factor, you can always check yourself by foiling. So if I foil this denominator, it should give me where I started back over here on the left. Now, from here, what happens to those x plus 3's? Hopefully you agree. They're going to cancel out, aren't they? So gone, gone. Final answer then for f over g, fully reduced, 1 over x plus 2. All right, so I'm going to box that in. That is f over g of x. Okay. All right, so now let's come down and let's talk about, it wants the domain for this. Okay, so for my domain, I've got to look at my two functions, my f function and my g function, but we've already done that. I had you do that from the top here, right? So they are both negative infinity to positive infinity. So we've got those two pieces. But then, because this is a quotient, the denominator cannot equal 0. So you got one more piece to overlap with that. So the denominator can't equal 0. You've got to go back to your original full denominator. You can't go back to the reduced one. You got to go back to that full denominator. So we've got to say here then that x squared plus 5x plus 6 cannot equal 0. Your very first step then would be to factor it. And we've already factored it, okay? So I'm just going to pull that answer down here. The only way to multiply to give me x squared, x and x. Most common way to multiply to give you 6, 3 times 2. Outside and inside, you got 2x and 3x. You want to get 5 out of that, so you make them both positive. And then it checks at the end. 3 times 2 gives me my 6. Now you set any factor that has a letter with it not equal to 0 and solve for x. So I set x plus 3 not equal to 0 and x plus 2 not equal to 0. Solve for x in both cases, so I pull that 3 over, so x cannot equal negative 3. Pull the 2 over, x cannot equal negative 2. All right, so now think about then, here's my full number line. F of x and g of x, I'm not going to do both of them, but f of x and g of x both say you get the full number line. Then what we just picked up is that we found out you couldn't equal negative 2 and you can't equal negative 3. All right, so I can't equal negative 2, so I got parentheses on negative 2 going in both directions. Get a different color. I can't equal negative 3 either, so I got parentheses at negative 3 going in both directions. So now, to anywhere my red, green, and blue are on top of one another, that gives me what my overall domain is. So essentially, I've got everywhere. I'm just going to have to stop where it would make it the denominator equal to 0. So it would be negative infinity to, hopefully you agree, negative 3. So negative infinity to negative 3. And then I'm going to go from negative 3 to negative 2. And then the last leg of the graph, negative 2 to the right forever, so negative 2 to infinity. Box that in. That's my domain. All right. Let's move over to letter E. I encourage you, if you'd like, to try letter E first on your own or get as far as you can with that one and then come back to the video. All right, so so coming over here to letter E, I'm going to do G over F. So same two functions. So I have x squared plus 5x plus 6 all over x plus 3. Pen's not cooperating. There we go. All right. Up top, you're factoring. We've already factored it a couple times now, so I'm just going to bring that over. Let's try this again. X and x, 3 and 2, a plus and a minus. All right, that's a 3 on there. I don't know why we're... All right, so now from here, those x plus 3's cancel out, leaving me then, that's a plus over here with that x plus 2. Sorry about that. That's leaving me then with x plus 2. That would be my final answer for the G over F. So now to find my domain, it's still going to work the same way. So to find your domain, it's still the two functions, f and g, which we know both of those are negative infinity to positive infinity for both of them, okay? Then the denominator can't equal 0, and this one really illustrates that, remember, the denominator cannot equal 0. If you go to the final answer, you don't have a denominator, and that could really trip you up. You can't forget your roots, so always go back to its original form, and we had a denominator of x plus 3. So we're going to set x plus 3 cannot equal 0. Solve for x, pull that 3 over, so x cannot equal negative 3. So now if we think about full number line down here, your f function and your g function say you get the full number line. And then the only restriction we picked up, the denominator couldn't equal negative 3. So place a negative 3. So anywhere the red and the blue are on top of one another, that would be our domain. So we can say then that our domain, negative infinity to negative 3, and then negative 3 to infinity. Final answer. All right, I'm going to come on down then to letter F. In letter F, it wants you to find f minus g of x. And again, any of these that you want to try on your own beforehand, by all means, pause the video and try them. All right, so remember, this means f minus g of x, so this means f of x minus g of x. Okay, so that's all that needs to happen then is I'm going to plug in my f of x function. So my f of x function is x plus 3 minus, plug in for my g of x function, our x squared plus 5x plus 6. All right, it's really important that you use, I use brackets, but you can use parentheses. It's really important that you use one or the other, because, especially when you're using subtraction, because remember that subtraction is like a -1 that needs to be distributed to every term in that second parenthesis or second bracket. So I'm going to bring down the x plus 3 and take that -1 and distribute it through. So I have minus x squared minus 5x minus 6. Combine like terms, and I have negative x squared minus 4x minus 3. I'll answer. We'll move over then to letter G. In letter G, it wants g over f of -8. So remember, that means g of -8 divided by f of -8. So we go to our g function. Everywhere we see an x, we plug in -8. So I have -8 squared plus 5 times -8 plus 6 up top. And on the bottom, I'm going to my f function. Everywhere I see an x, I'm going to plug in -8 plus 3. You could do one of two. I mean, you do one of two things. You could put the top in your calculator all at one time, put the bottom in your calculator all at one time, and get separate answers and then divide. Or I'm just gonna work through it, just kind of burn a step here. -8 squared will give you a positive 64 minus 40 plus 6. And then on the bottom, -8 plus 3, it's going to give me what, -5? Clean up top, that'll land you at 30. 30 divided by -5 puts you at a final answer of -6. I'll just point this out. If you plug in, if you're plugging in a variable, final answer is going to be in terms of variables. You plug in a number, final answer is going to be a numerical number. So that's a good comparison there, right side by side. All right, coming on down to letter H and I. I am multiplying in both of these. In letter H, I'm multiplying g times f. So we know that our g function, they have to be multiplied together. So I'm going to show you a way to do long multiplication. Take it or leave it. I never pigeonhole you and say you have to do it my way, just as long as you get everything multiplied together. But if you do it this way that I'm just going to show you, it will line all of your like terms up. So what I do is I always put the larger function on top, smaller one on the bottom. So I'm doing G up top times F down here on the bottom. And then, like I said, the only advantage of this is that it lines up your like terms. So what's going to happen is I'm going to go through and I'm going to multiply 3 times everything. So 3 times 6, 18. 3 times 5x, 15x. 3 times x squared, 3x squared. All right, so now I'm going to go through and I'm going to multiply x times everything. X times 6, 6x. I'm going to put it right underneath that 5x. That 6x was positive, so I'm going to put a plus sign in front of it. X times 5x, 5x squared. It was positive, so I'm going to put a plus sign in front of it. X times x squared, get you x cubed. And so now you just add down. You've got x cubed plus 8x squared plus 21x plus 18. Final answer. All right. And then lastly here in letter I, it just says to take f and multiply it times itself. So this means is f of x times f of x. F of x, both of those are binomials, meaning they have two terms. So in this case, it just makes sense to write them side by side and then FOIL, right? Do your first outside, inside, last. So do your first x times x, outside x times 3, inside 3 times x, last 3 times 3. Combine like terms, x squared plus 6x plus 9. Okay. All right, I'm going to let you flip it on over and pause the video and you try example 5 from top to bottom on your own. And you can check yourself by the solution key. And then I'm going to go ahead to that last page, which is with the difference quotient, and start talking about that one. The difference quotient will play a large role for those of you going on to take calculus, because what it allows you to do in calculus is to find the slope of a non-linear line. So if you think about it, we already know how to find the slope or average rate of change of a straight line, giving this formula here, right? Everybody should know this formula. Slope's y2 minus y1 over x2 minus x1. Well, if you don't have a straight line, how do you find the average rate of change between 2 points? The idea with calculus is that whenever you pick, you'll have a one order pair that you pick. You want to pick another order pair that is a really small distance away from the original order pair that you chose. So the idea here is that these two ordered pairs are super close together. So think about then that they have now been zoomed in on, but they are truly very close together. That h distance apart is like 0.0001. Okay, that's the idea, is that h distance apart from each of them is a really, really small distance apart. Hopefully you can read that graphic here very well, but if not, I'm going to go ahead and write them in here. I'm going to call this first order pair down here at the bottom is x comma f of x. And then the second order pair over here on the right, I have gone to the right h units, so its x value is x plus h, and then its y value would be f evaluated at x plus h. So they're telling us here that this is f of x, and this up here is f of x plus h. Okay. So I'm going to derive the formula for you, but you'll have the formula at your disposal whenever you take your test. Okay. So but I will derive the formula for the difference quotient for you. It comes from the formula that you already know for slope. Putting that here. We're going to think of this first order pair down here below as x1. Get this smaller. X1, Y1, and the second order pair up here is X2, Y2. All right, so then let's fill in what we know. So Y2, f of x plus h, minus Y1, f of x, all divided by X2, x plus h, minus X1, which is just x. So the only thing that can cancel out is down here on the bottom, x minus x. They're going to go away. And that is going to give you your difference quotient. Again, that would be given to you to be able to you'd be able to you should write that down, and that would be given to you whenever you take your test. Okay. Whenever you get to calculus, you'll take the limit as h goes to 0, just for just a little bit of a heads up. But again, it allows you to find the slope of a non-linear line, so a line that is not straight. All right, so how do we now utilize this difference quotient to find the slope of a nonlinear line? So in order to do that, the first thing that you find is f of x plus h, and that's the longest, hardest part, because what that says is everywhere you see an x, you're going to plug in x plus h. Then, once you have that piece, again, that's the longest, hardest part. Once we have that, we're going to plug that in for this piece right here. You're going to subtract f of x. F of x is going to be given to you, and then you can divide by h. And h is just a variable, so that you're just dividing by h, okay? You're going to plug all of these pieces into the difference quotient, and you're going to simplify. I did put a note up here. Every term that does not have an h, so without an h, should cancel out, okay? I'm actually going to do example 6 and 7 with you down here below. I would recommend, though, that you obviously come here and do example 6 with me. You try example 7 on your own. You get stuck, come back and watch the video, all right? All right, so here in example 6, I'm gonna rewrite my difference quotient formula for you here. I'm finding f of x plus h minus f of x all divided by h. All right, so like I said up here, the first thing that you find is f of x plus h. So I'm plugging in an expression, so my final answer here, I'm going to get an expression, okay? Everywhere I see an x, I'm plugging in x plus h. Right? Because if I had asked you to find f of 4, you would have said, okay, well, everywhere you see an x, you're going to plug in 4. I'm asking you to find f of x plus h, so everywhere you see an x, you're going to plug in x plus h. So there, every x turned into an x plus h. Now we just got to go through and clean it up. Like I said, this is the longest, hardest part. All right, so my next step, I'm going to bring down the 3. Anytime you have a binomial, meaning two terms separated by addition or subtraction sign, raised to a power, that power tells you how many times to write it times itself so that you can FOIL. So here, this is x plus h times x plus h. Now over here, I can go ahead and take this negative 2 and distribute it through. So minus 2x minus 2h. And then I have my plus 3. All right, I'm going to keep going. Next thing I want to do is I want to FOIL this x plus h with x plus h. So I do my first x times x squared. Outside, x times h. Just be consistent. Either write them as xh or hx, but it doesn't matter. So I'm just going to do xh. Inside, h times x, so another one of those. xh or hx, either way you wrote it, okay? Plus your last, h times h squared. Then I'm bringing everything else down. Inside there, you got like terms, xh and xh. That's going to give me 2xh. All right, one more step and we'll have the f of x plus h. Hopefully you kind of already thinking about what to do next. Take that 3 and distribute it through the parenthesis. So 3x squared plus 6xh plus 3h squared. Okay, that is your f of x plus h. F of x plus h. All right, so like I said, now you've done the longest, hardest part. You're ready to now go to the formula and plug in what you know. All right, and now at this point, you know everything. F of x plus h, that's this guy right here. So I'm plugging into my formula now. So I'm plugging in 3x squared plus 6h xh. All right, I'm going to use parentheses there, okay? Minus f of x. Again, like I told you from the beginning, f of x is always going to be given to you. Sure enough, here in the beginning, here's what f of x is. F of x is 3x squared minus 2x plus 3. You don't have to do any work. Then it's all divided by h. Okay. Now from here, just like we saw earlier, this is a minus sign sitting in front of that parentheses. So that's a -1 that's got to be distributed through. So I'm just going to burn a step here that I've got. Just bringing down that first parenthesis. I'm distributing my negative 1 through, so minus 3x squared, negative times negative, so positive 2x, negative times a positive, so minus 3, all over h. Now from here you should have terms that cancel out. If you remember, I had set up here, everything that doesn't have an h in it should cancel out. Everything that doesn't have an h in it is sitting back here at the back. So start from the back. So you've got a negative 3 and a positive 3. So cross them off. You got a positive 2x, look for your negative 2x. Got it. Cross them off. You got a negative 3x squared, look for the positive 3x squared right here at the front. Cross them off. Now, everything that's left has an h in it, and that's what you want, okay? So if you get to that point and something hasn't canceled out that it was supposed to, right? Everything that doesn't have an h in it should have canceled out, then, that's kind of like a midway checkpoint, okay? So now let's write what we have left over. I've got 6, let me get myself a little bit smaller. All right, so I've got 6xh plus 3h squared minus 2h. It's all divided by h. There's a couple ways you could do this. You could factor out the h up top because all three of those terms have an h in common. Maybe I'll do that. All three of these terms up here have an h in common, so I'm just going to factor it out. Right, what I have left over then, so that'd be 6x plus 3h minus 2, all divided by h. Right, because if I distribute that, that h through, I would have all of that back. All that I did was factor out an h. So if I distribute this h through, I'd have this right back, which is good. But what that helps me do then is I can cancel out that h, right? Because that one's being multiplied, it's now legal for me to cancel out 1 for 1. Final answer then, 6x plus 3h minus 2. And like I said, in calculus, you're going to take that one step further, and you're going to take the limit as that h goes to 0. All right, so again, I highly encourage you, first try example 7, get as far as you can, repeating those exact same steps there for the difference quotient. And probably 2 examples are not enough. You've got some in your homework. I'll also see if I can't post some more there online for you to work with as well. All right, so I'm going to go on down here, and I'm going to go ahead and work through this one, showing all the work. All right, so remember the first piece you find is that f of x plus h. Let's get this smaller. Everywhere I see an x, I'm plugging in x plus h. Remember that x plus h squared means to write it twice so you can FOIL it. Take that 2 and distribute it through. FOIL. Combine like terms. Distribute. Okay, that is f of x plus h. Okay, so now I am ready for plugging into my difference quotient formula. So remember, the difference quotient formula says f of x plus h. Actually, why don't I just go ahead and do that? Here's my f of x plus h. Subtract f of x. Here's f of x. 4x squared plus 2x minus 1. Parentheses there. And then all of that's divided by h. And that way I kind of saved myself just a little bit of writing there. All right, so just like last time, this is a negative 1 that needs to be distributed through there. So I'll come down here then. turning into a minus 4x squared minus 2x plus 1, all divided by h. Like I said, start back here at the back. Everything that doesn't have an h in it is back here at the back, and they should all cancel out. So you got a positive 1 and a negative 1. A negative 2x, positive 2x. A negative 4x squared, positive 4x squared. So kind of look what you have left over. 8xh plus 4h squared plus 2h all over h. Everything up top has got an h in it, so let's factor that out. Write what you have left over. Then it's legal at that point to cross off those h's. And then that would leave you with the final answer then, 8x plus 4h plus 2. That's your final answer. If you don't like that factoring out of the h like I did in these previous two examples, I will say that another way to approach, going from here to here is to do this. Since you're just dividing by one term, it's legal to do this. 8xh divided by h plus 4h squared divided by h plus 2h divided by h, and then go through each term and cancel out what you can. So like, for example, then in that first term, those h's cancel out, and that leaves you with 8x. In that second term, one h cancels out, and so that leaves me with 4h. In that last term, those h's cancel out and leaves me with the positive 2. So that's another way. If you don't like the factoring out that I did, that's another way to think about it too. All right, that finishes this section. Thanks a lot. Bye.